Hello. In this video, we're going to look at determinants. So in order to find a determinant, we are going to be looking at a matrix that is square, meaning it has the same number of rows as it does columns. We're going to first start out with a 2 by 2 matrix, 2 rows, 2 columns. And what we're going to do is we're going to look at our main diagonal, the number in the top left corner and the number in the bottom right corner, and then multiply those two together, so we get 2 times 3. And then we're going to look at our off diagonal, the number in the bottom left and the number in the top right. And we're going to subtract the product of those two. So we get 2 times 3 minus 2 times negative 7. So that's going to be 6 plus 14 equals a determinant of 20. Right, if we have a 3 by 3 matrix, we're going to have to do something a little bit different. There's a couple of different methods to do this. I'm going to focus on what we call the cofactor minor method. So for the cofactor and minor method, we're going to pick one of our rows or one of our columns. Pick the one that has the most zeros if you have zeros. This one doesn't have any zeros for this matrix, and so doesn't make a difference which row or column we pick. Your top left corner is going to be added, and then you're going to make a checkerboard. Let me do this kind of off to the side. So we're going to get plus in the top left corner, and then it's just going to be a checkerboard, and it's going to go plus, minus, plus, going across. It's going to be plus, minus, plus, going down. For our second row, we start with a minus, so it's going to be plus on the next one, and it just ends up alternating back and forth. And so here, since I've picked the top row, our signs are going to be plus, minus, plus. All right, so our cofactors are the numbers that are in our row or column that we pick. So in this case, we picked the row 4, 4, negative 3. So those are going to be our cofactors. The minor part of it is if we take that particular cofactor, so let's look at this 4 that's in the top left-hand corner first, and we're adding it because that's what in our checkerboard, that's the sign that we have. If we cover up the row and the column that contain that number, what's left is what we call the minor of that number. So that's going to be negative 4, 2, 5, 1. And then we're going to just repeat the process with each of those three. So if we now let's look at the second 4 there. That one's going to be a minus, so we're going to have minus 4, and then if we cover up the row and the column that contain that 4, what we have left is 1, 2, 1, 1. So that would be the minor for that second 4 there. And then do the exact same thing on that negative 3 at the end. It's a plus sign in our checkerboard, so we're going to be adding that negative 3. If we cover up the row and the column that contain that number, we're left with 1, negative 4, 1, 5. And now these are 2 by 2 matrices, just like we were looking at on the previous example. We're going to multiply our main diagonal, and then we're going to subtract the opposite diagonal. So we're going to get 4 times, our main diagonal is negative 4 times 1, or negative 4. Our off diagonal, we're going to be subtracting 5 times 2, which is 10. And then we get negative 4 times, our main diagonal here is 1 times 1. And then the off diagonal is going to be 1 times 2, so minus 2. Plus a negative 3 is going to be the same thing as minus 3 times our main diagonal is 1 times 5. And then we're going to subtract 1 times negative 4. All right, inside this first set of parentheses, we've got negative 4 minus 10. That's going to be negative 14 times 4 is negative 56. Our second parentheses, we've got 1 minus 2. That's going to be a negative 1 times that 4 is going to make that a positive 4. And then our last set of parentheses, we get 5 minus a negative 4. That's going to be 5 plus 4, or 9, times a negative 3 is negative 27. And if we do negative 56 plus 4 minus 27, we get negative 79. All right. These last two examples are determinant equations. So they're equations that involve determinants. But the process of finding the determinant is the same. So here we have the determinant of the 2 by 2 matrix XX37 equals 4. So on that left-hand side, we're going to do the same thing. Our main diagonal there, x times 7, is going to be 7x. And then 3 times x, multiplying our off diagonal, we're going to subtract 3x. That has to equal 4. All right, 7x minus 3x is 4x equals 4. So that means x equals 1. And then for our next example, we're going to do the cofactor and minor method, just like we were looking at. This one, just to change things up, I'm going to expand along that first row, or that first column instead of that first row. So for here, our checkerboard is going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. And so we're looking at that first row. That's going to be x times its minor. So plus x times the minor, negative 5, 5, negative 1, negative 2. And then we get minus a negative 2 times its minor, which is 1, 1, negative 1, negative 2. And then we get plus that last negative 1 times its minor, which is 1, 1, negative 5, 5, and that has to equal 2. All right. Taking the derivative, or the determinant of the 2 by 2 matrix, negative 5 times negative 2 is going to be a positive 10, minus negative 1 times 5 is going to be a negative 5, minus a negative 2 is going to be plus 2 times its minor, which is negative 2 minus a negative 1. And then we get minus 1 times the minor, 1 times 5, which is 5, minus a negative 5 equals 2. Let's keep simplifying. We're going to get multiplied by our x. 10 minus a negative 5 is going to be 15. And then negative 2 minus a negative 1 is going to be a negative 1. And then 5 minus a negative 5 is going to be 5 plus 5, or 10. So that's going to be 15x. We're going to get a negative 2 and a negative 10, so a negative 12 equals 2. Add 12 to both sides, and we get 15x equals 14, and so x equals 14 over 15. And so the determinant, or the x value that would make that determinant 2, is going to be the value 14/15. All right, I'll see you guys next time.